All right. Well, good afternoon, everybody. Okay, let's try that again. Good afternoon, everybody. Thank you for ending your day with me. My name is Dave Smith, and I am here today to talk to you about Bluetooth LE. And more specifically, we're going to talk about some of the changes that have come about in Bluetooth LE and the APIs as we've matured and come into Android 4.0 and the Lollipop release. Bluetooth on Android has kind of a checkered past. We first saw Bluetooth APIs show up for applications in 2.0, and those APIs were simple, but they were stable. And one of the reasons they were so stable is because the Bluetooth stack at that time was based off of a fairly well-known and stable stack called BlueZ. Is anybody here familiar with BlueZ? Ever heard that before? Okay, a couple of you. So it's a long-time Linux stack for doing Bluetooth communication, inside of the Linux operating system. And it was, up until very, very recently, the core stack that Android used as well. So all of the APIs that we had early on in Android worked quite well. But there were some issues with BlueZ. One of the biggest ones had to do with licensing, as is common with a lot of the pieces in the Linux kernel. The BlueZ stack was licensed under the GPL, which is something that is commonly very unfriendly to Android, being licensed under Apache, and there are some issues associated with that that I won't go into. But essentially, in Android 4.2, they decided that the BlueZ stack needed to go. And they were going to replace that with a completely new implementation that they called BlueDroid. This was brought forth by Broadcom, and it's pretty much solely maintained by that one entity with some help from Google. That was a stack that was Apache licensed. So it was much more friendly to the rest of the Android stack, but it was brand new. So as a result, we all saw at the application level that really from Android 4.2 on into the future, the Bluetooth stability of Android has taken a tank. And that's primarily because they've been starting over from scratch, essentially, on the Bluetooth stack and sort of building their way back up, on and from there. To kind of coincide with this, we got Bluetooth LE APIs at the application level starting in Jelly Bean 4.3, so just after they made that change. And as a result, many of you who have probably played around with this have realized that the original Bluetooth LE APIs were pretty shaky themselves. They were very finicky, they would kind of work. Half the time I couldn't even get a demo to work. But they were what we had and we loved them for it. As we've moved forward, the BlueDroid stack has continued to get a significant amount of updates. And probably, just looking at the commit logs, the amount of changes that have gone into BlueDroid from KitKat to Lollipop is probably one of the largest sums I've seen since it was introduced. So they've put a lot of work into BlueDroid. And at least from the limited experience that I've had with it so far, Bluetooth and Bluetooth LE specifically seem much, much more stable in Android Lollipop and hopefully moving forward. Okay, so that's good news. In addition, they've added a ton of new features, which is what we're going to focus on for the rest of the talk here today. So just a little background on Bluetooth LE for those who may not have a lot of experience with it. We won't go into too much detail here, but effectively, when we're talking about Bluetooth LE communication, there are one of 4 roles that any device can take on as part of this communication. There's a central role, peripheral role, an observer, and a broadcaster. Now, the pieces that we have on the right there, the peripheral and the broadcaster, those are devices that are designed to advertise their presence to other devices, out in the world. Whereas the central and observer are more scanning devices that are looking for other advertisers around that they can communicate with or connect to. Okay? The primary difference between a peripheral and a broadcaster is whether or not that device is connectable. So you think of a broadcaster as a device that simply advertises on a regular basis some packets of data out into the world. And all the interesting information that they have to say is in that advertisement packet. The device is not connectable. You can't get any further information by connecting to it and trying to get further data. All we have is the advertisement. These are effectively the beacon type devices that you see from a number of different companies around. Peripheral device, on the other hand, is something that you can advertise, but then a device can remotely connect to a peripheral and get further information from what are called the services and characteristics on that device. And we'll talk about how all that stuff is put together. So that's kind of the distinction between those two. And then on the opposite side of that, we have central devices, which are devices that scan and look for peripherals, and observers, which are really just listening for those broadcasts coming off of a beacon type device. Okay? Now, the central and observer role, we've had APIs to do that stuff on an Android device since the original Jelly Bean release in 4.3. Okay, so as soon as we had BLE APIs, those were the device roles that we were able to enact on a device. Now, with the Lollipop release, they've given us the APIs to do advertising as well and to generate what's known as a GAT server, which allows us to create peripherals and broadcasters on Android devices as well. So now, from an Android device, we can implement any one of the primary BLE roles, whereas prior we only were able to do about half of them. Okay? All right, so just a little bit of the architecture here. So the Bluetooth LE operates on what's known the general attribute or the GAT profile. It's basically just a giant table of key value data, where the keys are unique IDs and the values are any number of different things. And they just collect themselves together in logical groupings. So generally, a single device would be considered to implement a single profile. Now, if you're working with some of the adopted profiles that the Bluetooth SIG has defined for interoperability, like health thermometer or proximity profile or some of those things, then that profile and the pieces underneath it are well defined. You could just as easily define your own peripheral device that has your own custom collection of all these components, and we would still sort of refer to that overall device configuration as a profile. Okay, it's just the top level element. Then underneath that, you'll have a collection of one or more services. Now these services can be defined either by a fully unique ID or UUID, or if, again, they are part of the adopted profiles that the Bluetooth SIG defines, that will be defined as a 16-bit, what's known as an assigned number. It's still a unique ID, but it's assigned by the Bluetooth SIG so that everybody knows that each one of these services has the same ID no matter what. If you want to generate your own service that does something completely customer specific, you would create a full unique UUID, the 128-bit version, and you would use that to define your service instead. Okay? Services generally are logical groupings of functionality. So there would be something like a proximity service or a power service or a time service or maybe a thermometer service. And underneath that service would be one or more characteristics that are the individual values that make up that logical functionality. Now there may only be one, but there may be additional ones. Like for instance, let's take the thermometer as the example. Thermometer service may have a read-only characteristic that provides whatever the current temperature value is of the thermometer. And that's just the value of that characteristic. There may be a second characteristic on that same service that defines the units of the temperature. Maybe that one is read-writable so that you can configure what the units are that the temperature is reported in. And maybe if you write that characteristic, the device starts reporting its temperature back in different units. Okay? And that's just an example, but you can apply as many characteristics under a given service that you would like, whatever the individual points are that you need to read and or write on that specific device. Okay? Now, every single one of these elements, services and characteristics, each have a unique ID. And that's basically that key in the giant key value table that makes up what we call the GAT table. Okay? All right, so just a little bit about constructing UUIDs because it becomes important when you're writing the code. I mentioned before that there are 16-bit UIDs for the assigned numbers, but there are also full 128-bit versions. It turns out that if you just took one of those 16-bit UIDs and you passed it to the Android APIs, it would have no idea what to do with it, because that designation is not quite correct. It turns out that what actually is going on is that anytime you have one of those 16-bit UUIDs associated with an adopted profile, service, or characteristic, that is just shorthand for the 16 bits that fit inside of this top UUID that I have listed there, essentially in the red section. So inside of there, the actual UUID is the 16 bits that you're given, if you look at Bluetooth documentation, inserted into that larger, what they call the common base for all Bluetooth UUIDs. Okay, so every adopted profile service characteristic will have the same base UUID with those individual elements filled in. So you can see that the example I have at the bottom there with the health thermometer, which in Bluetooth documentation is defined just as hex 1809, the actual UUID you would need to put in code to connect to that service is 1809 stuck in that larger number that I'm not going to read. Okay. Questions on that? All right. So that's kind of the basics of getting us up and running with using BLE. Okay. Let's talk a little bit about what's changed from a year ago to now, essentially. When we had the original release and even up through the KitKat APIs, some of the functionality that was available to us, specifically when it came to BLE scanning. The first is that scans were very limited in terms of the filtering we could do. So essentially you could, from a device, you could start a scan and you could retrieve events for every BLE advertising device that would be picked up inside of range, regardless of what that device was. You know, you had to, in your code, determine either by device ID or by looking at the advertisement packets, whether or not that was a device you were actually interested in. There was no assistance from the framework to make that easier for you. There's essentially only one option, which is you could pass to the scan request a list of service UUIDs and ask the framework to only send you a callback if a device that advertises one of those services came about, so that you could kind of do some filtering out, but it was nothing more than that. Okay. The other real detriment that a lot of us saw with the early BLE is that it only allowed for active scanning. Basically what I mean by this is that scanning could only happen while the device was powered on or fully powered up. You couldn't start a scan and then let the device go into suspend mode. That would disable the scan essentially at the same time. That functionality was not drilled low enough into the stack to be able to have an active scan while the device was suspended. So if you were running scans all the time, you were basically murdering the user's battery. And there was no real balance in there. You either had to set up some sort of a wake-up schedule and turn scans on periodically and shut them off, or the device would never be able to go to sleep. Okay, so that was a big problem initially. Another fairly annoying thing for beacon applications was that if you started a scan, you could only retrieve one advertisement per device during that scan. So even though a beacon may be advertising every 10 seconds, as soon as you got the first advertisement, the stack would never deliver the remaining advertisements to you. You had to stop the scan and start it over again to get the next one. Well, if all the device has to tell you is in its advertisement packet, you kind of want to see them all. Okay? And so that was sort of a frustrating thing where we'd have to stop and start scans all the time just to scan for beacons. And then finally, as going along with the advertisement piece, Google kind of punted in the first release on this, and they would not give us any parsed data for advertisement records. So the advertisement data was basically handed to you in the scan callback as a raw byte array. They said, here, you figure it out. And the byte arrays weren't even properly sized half the time. You know, advertisement packets are 27 bytes, and usually the arrays were 60 or 70 bytes for some odd reason. It didn't make a whole lot of sense. But the data was there, and we could work with it. But it wasn't very finished. So fast forward to the latest release, and all of this stuff has gotten a lot better. Okay, so from the scanning perspective, we now have an array of filters that we can apply to scans to let the framework do the differentiation on what types of advertisements we actually want to see. We can filter on anything in an advertisement packet now. Device name, manufacturer data, advertised services, anything that's in that packet we can filter on, and the framework will do the work instead of us having to put all that stuff in our code. Okay? Batching of scan results is another really big one. This goes to the power consideration. So that now we can do a couple things, but with the filtration and the batching together, these are actually sent down to the hardware abstraction layer, so that the scan filtering and the ability to batch multiple scans together is handled by the hardware. So now the device can fully go into suspend mode with an active BLE scan, and then when the application wakes up at some later time, all the scan results as a single batch can be delivered to the application. So it allows for much lower power, longer term scanning than we ever had before with the Jelly Bean and the KitKat APIs. Okay? They also fixed the advertisement piece. So now if I run a scan and multiple advertisements come in from the same device, I can see them all. Thank you. So we don't have to worry about that anymore. And then we don't have to do manual work on scan records anymore. There are actual classes for scan records and advertisement data that we can call nice methods on to get out the device name and the UUIDs and all that stuff. Okay? So life is much, much better than it was before. Okay. So then on top of the improvements, the new features that we have really fall into these two categories. So we have the ability to advertise now from devices, and we have the ability to instantiate in our application what's known as a GAT server. It's basically just a way of saying that on my Android device, I can now set up my own table of services and characteristics and expose that to the world for other devices to connect to me. Okay? Those two pieces together make up what we call peripheral mode. You need both, right? You know, in fact, it's kind of interesting. Some of the GAT server APIs have been around since the original Jelly Bean release, but without advertising, there was no point to them. You know, they existed, but if you couldn't advertise out your presence, other devices couldn't connect to you. So we kind of needed the whole package, but technically speaking, peripheral mode means you have a GAT server and you can advertise, okay? Now, this is kind of a yay-aw moment a little bit, because while we've got this feature, it is required to be implemented at the chipset level. Okay, so this is a feature it's basically a hardware feature, which means you're probably not going to see it on every device just because it gets updated to the Lollipop release. Okay. In fact, even with just the Nexus devices that have been updated already, the Nexus 9 and the Nexus 6 do support this, the Nexus 5 and the Nexus 7 do not. Okay, so generally speaking, just because a device is getting Lollipop doesn't mean it's immediately going to be able to advertise. They've given you a new method to basically, you have to check on the framework to determine whether or not your device is going to be able to support this feature. Okay, yes, question?
There was some discussion about whether it's actually the chipset that's the problem or the certification. I don't know if you have any more insights into that.
The question was, there was some discussion about whether or not it was the chipset itself or the certification. I don't know. The way they've documented it anyway is that it has to be supported by the chipset. But I think really what it means is that what they've added is they've added APIs at the hardware abstraction layer, and the device manufacturer, for whichever reason, either does or doesn't support those additional APIs, but they have to do with the hardware. It's not something that they added in the Android stack so that it just magically gets turned on for all devices. It's a good question, though. Okay. So let's talk a little bit about the actual APIs here. So we're just going to walk through some of the code that you would be using if you were going to build some of these in your application. So regardless of where you're headed, the class that you're going to start with is always going to be a Bluetooth adapter. Okay. Now, there's a couple different code paths on this diagram here. So the red code path that I've got on the left-hand side is the way that you would do BLE scanning in Jelly Bean and KitKat. And then the green path over there on the other side is the way that we do BLE scanning in the new APIs using Lollipop. Okay. Now the old APIs do still work, so it's not like you have to run out and branch your code just so that you can support BLE on the latest release. If you use the older APIs, they've been shimmed into the newer ones so that they work appropriately, but you're going to lose some of the additional features like the filtering and the batching and some of those other things when they're available. But the basics are, either directly from the Bluetooth adapter, in the older case, you would start an LE scan with a reference to a callback. And that callback would just be handed a new device every time one that was advertising was picked up by the scanner. They've moved that into a new class in Lollipop called a Bluetooth LE scanner. It works effectively the same way, but now instead of talking to the adapter, you get a scanner from the adapter and then you call scan on that. Okay. But other than that, the APIs are roughly the same. In either case, there's still a scan callback, and the result of that callback is going to be a Bluetooth device. So Bluetooth device is just a reference to whatever remote device was found. You can have the name, the address, and some other basic information that was advertised about that device during the scan. Okay? Doesn't mean that you're connected to anything at this point. If you need to make additional steps if you want to start communicating with that actual device.
Is there any backward compatibility library?
for some of the filtration and stuff like that. As far as I know, they're not planning on doing anything like that. And there aren't any existing support APIs to do that now.
So we have to support both of these levels.
Yeah, so and the idea is, I think the simplest way to solve that problem for now is to use the older APIs. If you have a use case for the newer stuff, then at this point you would need to fork your code to support that on newer versions only. But the older stuff works fine. And you can see, just looking at the log messages on the device, calling the older APIs on a Lollipop device do trigger through a real scanner. So they're calling the new stuff, you just have no way to insert a filter. Okay. Now, if you're working in a beacon type application, broadcasters, observers, that sort of thing, that's kind of it. That's really all there is to it. You know, there's advertising and scanning, and once you've scanned for the devices and read the advertisement data, you're done. You wait for another advertisement and move on. But if we're talking about clients and peripherals here, then we need to move a little bit further down the line. So once we find a device that we want to connect to, so this is looking from the client side or the central side. Once that scanning device has found the remote it's interested in, then it will take that Bluetooth device, call the connect GAT method on it. Now there's a difference there because the Bluetooth device also has a connect method. That's used for the old Bluetooth Classic stuff, so it's something different than what we're talking about today. The connect GAT method, and of course pass that a callback, will give you a reference to a Bluetooth GAT instance. And once you have one of those, you're connected to that device and you can start reading and writing services and characteristics. Okay? So from the Bluetooth GAT, we can enumerate a number of pieces of information about that remote device. We can get any one of the Bluetooth GAT services that are enumerated. You can either list them all, or you can get a specific one by its UUID. And then from a service, we can enumerate all of its characteristics. Again, get them all, or get a specific one by ID. And then from characteristics, descriptors. Descriptors is another lower level discussion that we probably won't get into much. It's just another layer of segmenting data. Characteristics can have multiple descriptors. They're basically just like properties. Okay. All of that information is actually given to us as part of the connection event. So we can query all of that without having to do anything asynchronous with the remote device. As soon as we're connected to it, we can get service and characteristics information synchronously without any waiting. But if we want to start communicating with the actual device, then this is an asynchronous process. So with that connect GAT method that we had to initially deal with, we pass it a GAT callback. And that callback instance is responsible for triggering all of the events once the remote device has responded to whatever our request is. So if it's a Bluetooth, if it's a characteristic read or write, if it's a descriptor read or write, that we would make that request of the GAT object, and then sometime later, the GAT callback would trigger an on characteristic read or write, or to tell us whether that succeeded or failed and what the value was. Okay. Now there's an additional layer in here that I didn't mention earlier for notifications. So this green path that's in here has to do with characteristic notifications. And that's actually a really helpful feature if you need to subscribe to a characteristics value. So inside of Bluetooth LE, if you are interested in a specific characteristic and you want to get the contents of that value on a regular basis, and you want to know anytime that value changes so that you can update something on your side, the way that that's done is by subscribing to that characteristic with something called a notification. So in the APIs, the idea is that from your Bluetooth GAT, you would simply ask the framework to set the characteristic notification true on that specific characteristic. And then anytime whatever GAT server you're connected to, anytime that peripheral publishes a change to that characteristic, you'll just get a notification and you can update on your side. You don't have to keep calling read in some sort of a polling loop or anything like that. Okay? Now there are some caveats on doing that. We'll talk about them in a little bit. But generally speaking, if you're interested in some value, like say a temperature on a thermometer, and you want to update the UI every time it changes, you would probably subscribe to it with a notification. Okay? Now the only difference there is that the callback there is going to be on characteristic changed instead of on characteristic read. Okay? But other than that, it's the same path. All right, so advertising, this is some of the new stuff from Lollipop. So if you have a device that supports advertising, checking with that method that we mentioned earlier, you can get an instance of Bluetooth LE Scanner's cousin, the Bluetooth LE Advertiser, again from the adapter. And Bluetooth LE Advertiser allows you to start an advertisement using two pieces of information, the advertised data and the advertised settings. The advertised data is essentially the packet that you want to transmit from this device as the advertisement. So, these have builder classes associated with them, so you can define exactly what you want in it. Do I want to include the device name, include the transmit power level of my device, all these pieces that you want to add up. Keeping in mind that advertisement packets are limited in size. I mentioned before, they're about 27 bytes. And the framework will tell you if you've built an advertised data that is too big to fit in that packet. When you attempt to advertise, you'll get an error code that says advertised data too large or something like that. So you have to play around with this a little bit and make sure that the data you're trying to stuff in will actually fit. Okay? And then in addition to that, you give it the settings, which really just defines what transmit power you want to use, which is basically just defining how much distance you want to be able to cover with the advertisement. Whether or not the device should be connectable. So this is going to be different whether you're talking about a peripheral situation versus a beacon or a broadcaster. The timeout associated with it. If you ignore the timeout, you can just broadcast or advertise continuously until you decide to stop. Or you can set a timeout that says only advertise for, say, the next 30 seconds, and then the framework will shut that down for you. Okay? And then a latency mode, which is really just a couple constants to define the difference between low power versus low latency, which is really just how often do you want to advertise. Low latency is going to be advertising very quickly, maybe even multiple times a second, whereas low power is going to be much, much less often. Okay? All right, now, if you are using the older APIs, I figured I would leave this slide in just for you folks. You may still find yourself having to parse scan record data manually. So I wanted to just briefly go over what that is. So this is the method that's in the scan callback that you would see on the Jelly Bean or KitKat APIs whenever a new device is picked up by a scan. And notice that we have the device, the receive signal, and this raw byte array that represents the advertisement data called the scan record. Now, in those releases, we didn't have any classes to parse them, so you have to manually chunk through it yourself. Really, all this data is it's just an array of these advertisement data structures, which are just these little payloads consisting of a length, type, and then a variable payload of whatever the length was defined in the first one. So it's fairly easy to parse through. You just have to realize what's in there and do it yourself. And the types themselves are defined, again, by the Bluetooth SIG. And each type identifier will be device name, service UUIDs, all those pieces that we talked about before you could stick in one. You just have to go through the process of chunking them out yourself. I won't probably be going through it today, but in the example repo that I've given you, there is a sample parser for chunking through those things that was used back on the older APIs to do some of these examples. Okay? All right. So then just a couple things that are good to know that you probably won't see in the documentation anywhere. There are a couple hard constants that are defined inside the Blue Droid stack, and these have evolved a little bit over time, so it's interesting to note based on the version you're trying to support as well. The first is that there is a constant defined for the maximum number of concurrent notifications you can be registered for. So as a client, you can only register for a maximum of 4 concurrent notifications. That means you can be registered or subscribed to 4 different characteristics to be notified on, for any given event. That number was 4 in Jelly Bean. It was increased to 7 in KitKat, and as of the Lollipop release, they bumped it up to 15. Okay? So depending on which Android version you're running on, your device may fail to subscribe for a notification if you've already hit that limit. Okay? So just something to keep in mind. Then additionally to that, there's another constant they've defined, which is the maximum number of connections. So as a client, I can connect to multiple peripherals at the same time. I can connect to this device, then scan and connect to another one without having to disconnect from the other. That maximum, again, has been a bit variable. It was started out as 4 in Jelly Bean, evolved to 7 in KitKat, but this one has stayed there. So even in Lollipop, 7 is still the maximum number of devices you can connect to at any one time. If you wanted to connect to another device, you'd have to disconnect from another one first. Question?
Yes. Those limits, they sound like they're particularly hardware-oriented. Is there any, software-oriented, is there any hardware limits that are actually maybe holding us back in some way?
Sure. So the question was, are those software, those are software limits. Is there anything in hardware? The answer is not as far as I know. So you're right that those limits they're hard-coded constants in the Bluetooth stack. Now, because of that, and because they're not in any of the hardware abstraction pieces, they're going to be the same on every device. So this doesn't mean that these are numbers that manufacturers can define based on whatever piece of hardware they've chosen to implement their Bluetooth on. They will be consistent, but they are defined in software. And as far as I know, they're not defined that way because of any specific hardware limitations. I'm not really sure why they chose those numbers, but that's the numbers that are in the stack for sure. Good question. One more question?
Is that for the platform? I mean, if there's another app running and it has connections, so is it at the platform level?
That's a good question. The question was, is that at the platform level or per app? That is for the entire stack. Yes. Good question. Okay. Yes, one more.
Does the system do any coalescing, say two apps, one in the same filter?
Ask the question again. I didn't quite hear the last part.
Does the system do any coalescing of filter requests? So if two apps wanted the same type of filter, would it realize, oh,
Good question. So does the system coalesce filters together? The answer is it's up to the device manufacturer. Because that specific piece that they've added in Lollipop is part of the hardware abstraction layer. So it's up to each manufacturer to implement their HAL driver, essentially, as to how they would manage that on chip. So some might not. It's up to them. Good question. Okay, so let's jump into some of the examples. All right, so I've got a couple examples to show you, and what I'll probably do is show you the example first, and then we'll walk through the code. So let me switch over here. Okay, so the first example that I'm going to show you is I have one in my hand and a couple around the room, these little key fob beacon devices. These are made by a company near us called KST, and this is just it's a simple little temperature sensing beacon. So it has a temperature sensor on it, and it advertises that temperature value constantly so that we can read that back from other devices. And I've got them around the room, and I've got one up here. So I've got a little Android application that I will bring on screen for you, that simply goes out and scans for these devices and then displays them in a list here. Now this is it's constantly scanning, and as the advertisements come in, we'll see the data inside of this list update. So it just displays the device name, the temperature value that was advertised in the packet, and the device address and some other information. And the coloring is based on the temperature. So as the number gets higher, it gets closer to red and closer to bleed, because I'm a great UI designer and that's the way I put it together. So this is a basic example of monitoring other beacon devices that are advertising their data. But what I can add to this is if I flip on my Nexus 9 here, now you all know my password, I can flip on another example that I have here, which is an advertiser. And as soon as I do that, you see the Nexus 9 shows up in this list as well. So the Nexus 9 is, I have another application that I've coded to do the same advertising packet format as these little beacons. The only difference is I've wrote a little app that I can control whatever the fake temperature is, and every time I hit the update button, it will change change what that advertisement is to the new data. I can try. Let's see if autofocus works. I may not be able to. Is that better or worse? Yeah, right. Well, we'll have to stick with that, sorry. Because of the focus, what you may or may not be able to read, those of you up close may be able to see it, but as I change this value, not only does the temperature value change, but the device address is actually going to change too. You'll see why that's the case inside of the code, but it turns out that every time we restart a new advertisement with the new APIs, it actually uses MAC address randomization. So it doesn't use a hardware MAC address, it generates a new one. So every time I start a new advertisement, it will generate a new address. Something that's very important to realize if you're expecting that to be the same on every device.
why do they do that?
Don't know. I mean, beacon devices use that as a security mechanism, but they tend to do that in a pattern. Like there are some beacons that will randomize their MAC address, but they do it every so often. This only happens when I manually start and stop a new advertisement. So I think it's just part of a new advertisement gets a new instance and moves on from there. Yeah, I think so.
I got a question.
Yes?
Is there any way to identify the device then? Like, for instance, does your phone recognize it's the Nexus 9 even though the address changed?
Well, my phone does, but it's because I'm looking for the device name. So in this specific case, I can rely on the device name as the only exact unique piece that I'll get in every advertisement. Okay, so let me flip over to the code, and we'll see how that works.
There isn't any way to detect distance, is there, in Bluetooth?
Yes and no. So one of the pieces, the question was, is there a way to detect distance? One of the pieces of information that you put inside of an advertisement is the transmit power level. The reason that they do that is so you can do some basic calculations between transmit power and the receive signal strength to try and make a rough determination of distance. Now obviously all the factors between is it through a wall, is it rainy out, all that stuff is going to give you, not allow you to get an exact number. But the RSSI by itself is not enough. You have to know the transmit power to be able to figure out the difference. And so in proximity-based BLE situations, those have the transmit power defined in their advertisement so they can do that math. The beacons that are made by the Cupertino Fruit Company, essentially that's how their near, far, that type of stuff works. It's based off of that difference. Good question. Okay. So let's start with the scanning piece. And I'll show you both pieces here. Open up some classes so I can take that off. All right, so first thing to realize is when you're working with these APIs, they're not going to be supported on every device. So you're going to want to make sure that if nothing else, inside of your application's manifest, you declare whether or not you require use of Bluetooth LE. And you can do that using one of these standard uses feature declarations that we've used a million times before, defining whether or not it should be required. Now in this case, because this is required, this means that places like the Play Store are going to filter out my app from devices that don't have these features. Right, so I get some assistance there. If you don't want to force that level, you can always do this as a non-required check, and you can check at runtime if you just want to disable certain portions of your application based on whether or not that support exists. I'll show you that code in a minute. You're also going to need to make sure that you have the Bluetooth and the Bluetooth admin permission. You're not going to be able to do pretty much any of this without both of those. Okay. All right, so first piece that we'll look at here, this is the scanning device. So this is the one I had running on the handset that was going out and looking for the different beacons. So a couple of pieces that we're going to need. We're going to need our Bluetooth adapter. Bluetooth adapter always comes from the Bluetooth Manager System Service. Okay, so we get the service, we get the adapter, and in Lollipop's case, we get a reference to that scanner from the adapter. Okay, so those are the pieces we're just going to need to hold on to. Then to do some basic checking here, anytime we move into the foreground in this app, I'm going to verify that this device has the support it needs first. So the first thing I'm going to make sure is Bluetooth even on? Okay, so just basic check about whether I got an adapter or whether the adapter says things are enabled. If neither of those are the case, the framework provides an intent. You can fire the user into settings to turn Bluetooth on first. Okay, because otherwise none of this is going to work. Then additionally, if you wanted to check for Bluetooth LE support at runtime, you could do that by asking the package manager for that feature. This does the same check as what I put in the manifest. This is just doing it at runtime. If you maybe didn't want this to be a hard check, maybe you just want to shut off this part of your app, then you could do it this way instead. Okay. And then we're just going to start a scan. So as long as this app is in the foreground, it is scanning. And the way that this works is our Bluetooth LE scanner just takes these three pieces of information to define what the scan should be. So it's the scan filter, the scan settings, and the callback. Okay? So the scan filter defines any information that we want to tell the framework, these are the specific devices I'm interested in. I could add things like device name and other pieces in there as well. All I'm interested in is I only want you to give me devices that advertise that one service that I was talking about, which has the temperature data in it, okay? Which is what all these beacons do. All these beacons advertise that temperature data inside of a thermometer service. And so I have that UUID for that service defined as a constant somewhere. And then that information, I only want devices that are advertising that specific service. And then the settings are used to define the data about the scan. You know, should I do a low latency scan, a low power scan, you know, that type of information, so that I can, a low latency scan is going to pick up devices much quicker, but I'm obviously only going to want to do that if I'm in the foreground. A low power scan would be the type of scan that I could run, and then the user could leave the app, shut down their device, and the scan could still run safely without completely destroying the battery. Okay, so there's a couple different options in there that you can pick from. And then the callback is just where you're going to get more information as the scan progresses. So we start the scan, and then the information will come inside of this callback. Now there's one of two options. There's scan result and there's batch scan results. So I mentioned that if in the scan settings I had enabled batching, the way that I do that is by telling it to delay scans by a certain amount of time. And that tells the framework that it can batch results up to that amount and then deliver them all at once. If I had done that, then the callbacks would come in here as a group. But in this application, it turns out they all end up coming through individually one at a time while we're in the foreground. So each one of these scan results has a fully nicely parsed scan result object that I can look at. No more raw byte arrays. And so inside of this little helper I've created, I basically just take the scan record from that advertisement and I construct another model object for it. I just call it a temperature beacon. So I can jump into the beacon real quick and we can see that really all this is just a piece of data that holds the receive signal, address, device name, and the current temperature value. And so those values are pulled out of that scan record. Again, I can get them very nicely from the framework by saying I would like the device name, please. I would like the service data associated with that UUID. And it does all the work of parsing through the byte array, finding the right chunk, and returning back the value that I need. Okay? So that's all done for us. Now, the structure of the service data in this case is custom. Right? Like it's not defined by the Bluetooth SIG or anything. It's defined by the guys over at KST that made these things. They basically said that inside of their advertisement for this service, the value for the temperature will just be a 2-byte packet. Basically will be the degrees in Celsius, where the high byte is the actual degree, and the low byte will be 0 or 1 based on whether or not it's 0 or 0.5. They only have half a degree resolution on their temperature sensor. Okay? So they define that, they tell me what it is, I put it in. Okay? If we were building an application around an adopted profile, we would get all that data out of the profile spec from the Bluetooth SIG. Okay?
How big is the service data record?
The advertisement data record is 27 bytes. Yeah. So the idea is that the entire advertisement is 27 bytes. What you fill it up with is not really defined. So if you only had that one element in your ad data, it could be 27 bytes of service data. If you added the device name, that would truncate how much space you had. So it doesn't really matter. Each one doesn't have a specific space as long as the sum total of them is not larger than the packet size.
And how quickly can you advertise?
You know, I have not done testing to know how quickly Android advertises on the low latency mode. Basically, you set it to low latency, and that advertises as fast as Android is willing. My guess is it's definitely more than a few times a second, but I haven't actually timed it yet. They don't document what that actually is. So, good question. Okay, so we're just taking this data out of every advertisement we get, and then we're just throwing it into that list that you saw in the UI. And every time I get a new advertisement, I just replace that existing element in the list and update it so you can see the result. Now, something to point out here, and this is true kind of across all of the Bluetooth LE callbacks, but none of these callbacks will come to you on the UI thread. Okay? So if you want to do anything in a scan callback, a GAT callback, anything, if you want to do anything touching the UI, you're going to have to post that result using a handler or some other mechanism to get that onto the main thread before you try to touch a view. Okay? So for instance, in this case, I'm taking that data and I'm sticking it into my list adapter that I created, but I have to do that by posting a message to a handler on the main thread. I can't do that directly inside of my scan result callback, it will fail. Okay, it'll tell me that I can't touch a view because I'm on the wrong thread and all that fun stuff we've seen a million times. So just keep that in mind. Okay, questions so far? Yes?
You're saying there's a software limit to the number of devices you can connect to for the stack, the entire stack.
Correct, the stack defines that limit.
Right. Is there anything in your code that will indicate, okay, you can't connect more than 10 devices or,
Well, essentially the indication is when you attempt to do so, you'll get a failure.
a failure to get what, got the manager back or?
No, a failure to make either the next connection or subscribe to that next notification. So that attempt will fail. Now, I will admit that at least on the connection side, the return code is not real obvious to the fact that that's the reason why. They just give you a generic failure that you can't really determine that beyond maybe much any other failure. But at least that's what you can look for, is you attempt to connect to a device and it fails. And you'll know internally that's why.
Okay, there's no indication yet.
Not really. No, the only failure code, there's only 2 return codes for that right now. There's GAT success and GAT failure. Hopefully they will add some more as time goes on.
So if it got out of range, you get the same failure?
No, that would be a disconnect. So, and we'll talk.
Before you've made the connection?
Well, so if we're talking about a situation like this where there's no connection made, then something goes out of range, the only thing that's going to happen is you're going to stop seeing the advertisements from that device. In a connection case, if you're connected to it and it goes out of range, you will see a disconnection event.
Or if you try to connect to them and you haven't connected yet, at the connection attempt time,
That would fail.
and that would be the same error.
Yes, as far as I know.
So you
Yes.
couldn't distinguish whether you hit your max or whether it was out of range.
To my knowledge, that's correct, yes. Okay. All right, so then just quickly here, this is the same example using the older APIs. So this example runs on older devices as well as a new device. And if you run it on, say, a Jelly Bean or a KitKat device, it's going to launch this activity instead. Excuse me. And so the functionality is pretty much the same. I just want to quickly run you through the difference in the API so you can kind of see it if you've never used the older APIs before. So basically, we still get a reference to our Bluetooth adapter, but there's no scanner anymore. It turns out in the older APIs, the Bluetooth LE scanner didn't exist. We did this a different way. All of this code to check for Bluetooth is the same. And as far as setting up the scan, we instead would have called start LE scan directly on the adapter. Okay? Now we still pass a callback, and we still have the opportunity to do some filtering. But the only filter it supports is a list of UUIDs for services. We can't filter on anything else in the older versions. Just turns out in this case, that's all I need. So I am actually leveraging that in this case. Now the other thing that's going on in this older example, based on this block of code that you can see here, is that because I can't see all the advertisements unless I keep stopping the scan, we have this runnable setup that basically starts the scan for 5 minutes, then shuts it off, and then for 2 seconds turns it back on and just toggles it back and forth while we're in the foreground. The reason, again, is because if I didn't do that on older versions, I would see one advertisement from all my beacons, and that's it. So I wouldn't be able to continue to get those updates of whatever the current temperature is unless I stopped and started again. Luckily, that's been fixed. But if you have to deal with that on older platforms, you have to do a mitigation strategy kind of like this. Okay, and then similar thing with the scan, but back in the old days, we had to parse these things by ourselves. So we got that raw value, and I just have a very simple parser in here that you're welcome to look through later on that basically just chunks through those AD records in this raw byte array and turns them into a simple structure that you can get things like the name or the service data or stuff like that from. Okay, so if you want to see an example of how to parse the data yourself if you need it, there's one in here. I'm not going to spend too much time on it now. And luckily, if you're supporting only Lollipop, it's done for you. Okay. So let's take a look at the advertising side. So what happened when I flipped on my Nexus 9 and it magically added itself to the list of devices that I could see? I go to my other project here, my advertiser. You'll see it's actually pretty dead simple. Okay, so we have the simple activity, and that's the one that had the slider on it, so I could set the temperature and hit the button and go from there. In this case, I have the Bluetooth LE advertiser off of the adapter. And then anytime we're in the foreground, I'm going to check those same support issues. Now there's one more to check this time. I need to make sure that the device I'm running on supports advertisement, because that's different than just supporting the BLE APIs. Okay? So that's checking whether or not this multiple advertisement is supported method. If not, then this is no good to me. I can't do this on this device. Okay, so inside of the advertising, same basic format. I have a settings and a data. The settings defines the information about the advertisement. The mode is how frequent, so low power versus low latency. Is this device connectable? In this case, no, because we want this to act as more of a beacon. I'm just advertising data. I'm not setting up any connectability here. Timeout 0 means advertise forever. But if I want to set this to an actual value, I can tell this to time out after, say, 15 or 30 seconds and stop advertising at that point. Okay, if I just want to do this in short bursts. And then what's the transmit power I want for the advertisement? There's a low, medium, and high setting. Okay. In the add data, I want to make sure the device name is in there. In this case, I added the transmit power level. And the data that I'm including is that current temperature value. So whatever was set on that slider on the UI gets packed into that 2-byte array that I defined earlier as part of the KST protocol. And that gets added as the service data for this advertisement. And it just gets built all together into an add data packet. And then using my advertiser, I tell it to start advertising. And that's pretty much it. There is a callback, but the callback only exists to tell you whether or not you succeeded to start advertising or whether there was a failure. Okay? Now, multiple applications can be advertising at the same time. So one of the reasons that you might get a failure is there's a maximum of, I believe it's 4 applications that can advertise at any given moment. So, and luckily they did a little bit better job with the error codes here. In this case, if you fail because there are too many advertisers already, it will tell you that. You also can't restart an advertisement to the same callback. So if I called start advertise and then called it again later, I'd get another error saying that I'm already advertising, for this particular instance. Okay, so you'd only have one of those at any given time. So a little bit better error handling in the new stuff. But other than that, not a whole lot of interesting to really see here. And so this data is just going to advertise constantly, just like my other beacons. Now, one thing to note is these advertisement data packets are immutable. The only way to create one is using this builder. I can't hold on to a reference and say, well, actually, I'm going to change the temp value to this now and do all those things on the fly to modify what's going on inside of the advertisement. So what I have to do, unfortunately, and this is why you saw the MAC address change every time I updated the piece there, is that in order to modify the ad data, I have to start a new advertisement. Okay, so that I can create a new ad data object and I can pass that to start advertise again. Okay, so inside of the click handler for that specific button that I was clicking, there's basically just a method that I use to stop the current advertisement and start a new one with whatever the current data is inside of the UI. Okay, that's a little bit unfortunate. Maybe that'll get fixed in another version, but at least for now, the advertisement data you provide to the framework is static. If you want to change it, you have to restart your advertisement with new data. Okay. Yes, question?
Could you tell me what the use cases
iBeacon is all about proximity, right? It's how far away are you from something, and then there's some unique identifying information about what that thing is. This is essentially, could be the same idea, right? I could have this at the front of a store or something like that where that I need to uniquely identify this thing and have other devices be able to determine how far they are away from this specific maybe point of sale or something like that. And in order to do that, this has to be advertising information like where it is and how the current power level so that people can determine proximity. That's just one example kind of stealing from what Apple's doing, but maybe there are others as well. Okay, so the next example that I'm going to show you is a little more involved. And it might be hard to see with the lack of focus on here, but we'll see. So what I've got defined here is now I'm going to show you a basic client peripheral communication. So I've got the Nexus 9 is going to have an application on it that's going to set up a GATT server. And it's going to provide some very basic information. It's just a very simple server that has one service and two characteristics. And the characteristics are going to define how much time has elapsed since some given offset, and then another characteristic that allows you to set when that offset was. Okay, so some very basic information, and at any time, another device can query that service to get either one of those pieces of information. Okay, so the GATT peripheral has pretty much no UI on it in this case. All that is going to show up on this screen is anytime a device connects to this server, it's going to show that device in the list. Okay, the UI that hopefully you'll be able to see okay is actually going to be on this device. And actually, what I might do is just put them on top of each other, so you can see it a little better. But basically, I just have a couple buttons where I can use this information to get the current value of the characteristics, and in the case of the offset value, there's a little bit of UI in here that I can use to set the current offset that should be resident on the server device. Okay, and it's probably easier to explain if I just run it. So first thing I have up here in the corner is a scan button, and that will run a scan for any devices in the area. And since my server is active, it's advertising, so it shows up in the list here as my Nexus 9. And then I can connect to that device, and you see it shows up here in the list. And then what shows up down here is a current time value. So basically what we're seeing is the number of seconds that have elapsed since whatever the offset is. Right now the offset is 0, so that's what, January 1st, 1970, or whatever that is in Pacific time. But I've got some basic pieces in here where using this update button, I can set what the new offset should be. So I'm going to say, well, I'd like to figure out how much time has elapsed since, let's say, well, no, let's go back. Since 4:55, so 5 minutes ago. And that will go to the device. You can see there's a little notification on the server device that says it received that characteristic right. And then the data that shows up in that counter is now based off of the time that has elapsed since 5 minutes ago and now based on this device's current clock. Okay. Now the other thing that's going on, which you may or may not be able to see because of the focus, is that every few seconds it's counting up. Okay. And that's going on using a notification. So this client device has subscribed to that characteristic to say, anytime this characteristic changes, notify me so I can update the UI. And so the changes are not going on because the client is constantly polling the server. The server is triggering a notification every so often when it decides that something has changed. Okay?
The offset is computed on the smaller phone.
On the server. So the server, basically that's a value that gets passed over to the server, and the server does the math of current time versus what you gave me and returns that back as a characteristic. Okay, so just kind of a semi-contrived, simple example. Okay.
Have you tried extending that to see how quickly data can be sent?
I'm sorry, ask that question again?
Have you tried extending that to see how quickly the data can be sent for notification?
No, I haven't. You mean like how quickly I can pump notifications before they're not get received anymore? No, I haven't. I imagine it's actually pretty responsive, but I haven't timed it. Right now it's happening every 2 seconds. I think I could probably safely do it without any concern a couple times a second, but I haven't really tested that. All right, so let's look at the code for this example. So we've got two activities, one for the peripheral and one for the client. And as I mentioned, I've just defined just a very basic GATT server with a service and two characteristics, one for the elapsed time and one for the offset that it should compute the elapsed time from. Okay? So these are just UUIDs. Since this has nothing to do with any adopted profiles, I just generated my own UUIDs. You know, if you have a Mac or Linux system, you just run UUID gen on the command line and take the output, right? Or you can generate them any way you like. So we just have those three parameters defined for this piece here. So on the peripheral side, some of the same code we've seen before, because the first thing we have to do is set up advertising so that other devices can find it and connect to it. So all those pieces are the same. So we're still going to have our Bluetooth adapter, and our Bluetooth adapter is still going to have a reference to a Bluetooth LE advertiser. So all those pieces are the same as they were before. What's new is now I'm also generating an instance of a Bluetooth GATT server. Okay, and this is generated by calling OpenGATT server on the Bluetooth manager and giving it a callback. Okay. Now the GAT server callback is going to be responsible for handling all the incoming requests. So anytime a characteristic read request, write request, anything like that, it's going to be coming in through that callback. Okay. So we just call open GAT server, and that registers that instance with the framework. I have to do a little bit more work here, which is I have to define on the server the services and characteristics. Okay, so this gets a little code heavy. I almost wish I could do this in XML, but basically I can define the service that I need using that UUID and a characteristic for each one of my elapsed time and my offset. Okay, and I just pass the UUID for that characteristic or service and the properties associated with it. So my elapsed time characteristic is defined to be read only. So it's only defined to have the read permission on it. And it also supports notifications. So clients can subscribe to this for the purposes of notification. You have to define that as a property on the characteristic. The other one is readable and writable. So I have to define the properties and permissions on both of those. If you don't do this and you try to read or write the characteristic, it's just going to fail. Okay, so it's important to get these bits set appropriately. Add the characteristics to the service, add the service to the server.
What's the difference between write with response and then write without response? Do you set that up here?
Yes, well, no, you don't set that up here. And maybe we can talk about that in a little more detail offline. Because that's a property you define on the actual write,
Okay.
as opposed to on the characteristic.
Okay.
Okay, so we define that server and it's initialized. So now, anytime a device attempts to connect to this and tries to query for one of these services or characteristics, the framework will route those requests to our application because we've told the framework about our server and it knows what services and characteristics are on it. Okay. All right, so then let me jump down to the advertisement piece real quick. There it is. Advertising code, not really any different. We're advertising our one service so that other clients can filter on it. That's just making it easier on them. We include the device name there. And then we pass that advertisement off. Okay, so this is just advertising all the time. Now the one thing that's different here that's important, this is a connectable advertisement. Okay, if I forget to set this because it defaults to false, I've essentially turned this nice server I created into a beacon. Nobody's going to connect to it. Okay, so that's important to realize. All right, so that's all set up. And then eventually later on, when clients connect to me and do all these other things, we'll start seeing events going on in the callback. So I'll just go through those quickly here. So the callback has methods like connection state change. This tells me that a device has either connected or disconnected from my server. So I can check which one of those events it is. And in this case, I'm just posting that to the UI so that it can add it or remove it from that list. Okay, nothing crazy there. Characteristic read request. This happens anytime one of the clients asks to read one of my characteristics off of that service. So I have to figure out, first of all, which characteristic were they asking for. Are they asking for my elapsed time or my offset value? And then send back a response to the device using the APIs. So there's a send response method that I use to provide the value to the read request for whatever the characteristic is. Now, read requests by default require a response from the service. So even if, for some reason, somebody sends a read request to my device that it has a service or characteristic that I don't understand, it's not part of my device, even if that manages to happen, you want to make sure that as a default, you always send some response back, or that could essentially lock up the client waiting for a timeout or something like that on the other side. So in this case, I'm sending back a failure with no data. But you want to make sure to handle that case as well. Okay, and then characteristic write request. We have one characteristic that's writable, and it's that offset value. So if a client attempts to write to the offset, then we need to make sure that that's the characteristic they're asking for, and then we can steal the value out of the characteristic. Now notice that the value from the write request is not in the characteristic object, it's given to you separately. Don't ask me why they did that. But if you call get value on this characteristic, it will be null. The value they attempted to write is right here. Okay. Now the question was asked about write no response versus a default write. On the server side, that determination is made using this value. So if the write was made with the no response bit set, this will be false. Otherwise, this will be true. So on a server, you're simply responsible for determining do I need to send a response? And if I do, same thing as we did with the read. Okay. Then the idea of setting that or not setting it is responsible on the client side. Okay. And then we pop that toast that some of you may have seen when the offset actually went through.
So on the client side, does, on write, does that get called after it really got to the client, after it really got to the peripheral and got a response?
Sure, so we're going to see the client in a second, but yeah, the question was, does the on-write on the client side get called, on-write on the client side gets called when the response comes back,
Okay.
essentially. So, question?
So if the write request doesn't match one of the characteristics we're exposing, should we still send that response, but with like Bluetooth GAT failure?
You know, to be honest, to be super robust, probably. Generally speaking, you should never see those because the framework shouldn't route them to your application's callback, since they're not defined as a service or characteristic on your server. But kind of like I did before, if for some reason something happened, you'd want to have a catch-all in there, so you probably would want to have maybe a response error or something that gets thrown back. It's probably good practice. Okay, last thing in here is the notification. So a couple things happen. Anytime the write happens, or inside of this server to sort of mimic a change, because I mean, since I'm basically giving it elapsed time, basically it changes every second. But I've decided that I'm not going to trigger the notification that often. Instead, I'm just running a simple handler that pulls every 2 seconds. And so every 2 seconds, we're faking a way of saying, yes, the characteristic has changed. Okay, it changed again. And so either every 2 seconds or anytime the offset is changed, we just pass this notify method here, which goes through and for that one characteristic, passes the current value and calls this notify characteristic changed method to all the connected devices that I have. Okay. And then any devices, it's kind of nice. From this side, I can just do it to any connected device I've seen, and the framework will deal with whether or not they've actually subscribed on the client side and determine whether or not they have to get pushed in. Okay. So I can just notify everybody that a change has occurred and go from there. Okay. Real quick, we'll go through the client side. So client side looks very, very similar. The one major difference comes inside of the connection and the communication, but very briefly I'll show you the scanning piece. So here inside of this we're using our Bluetooth LE scanner again, looking for those advertisement packets coming from our device. We're looking for only devices that have our custom service advertised, so that way we filter out everything else we don't care about. And then inside of the scan result, we're just going to add those to a collection, which is what was showing up inside of the overflow menu up there. So I had the scan button in the overflow, and then the options menu basically just defines the overflow to be my scan button plus a button for every device that I have in my collection. Okay, so as they scan, they just pop in there. It's just an easy way for me to keep it off the UI. So when I selected that Nexus 9 out of the overflow, that's when it attempted to make the device connection. So from that Bluetooth device, connect GAT, give it the callback. And the callback has very similar methods on it. You know, on connection state change, services discovered, I'll talk about that in a minute, characteristic read, and in this case, characteristic change. Now there are other methods on here that I'm not overwriting because I don't need to. You know, there's on characteristic write, on descriptor read and write, all those other ones I showed you in the slide. And basically, there's just a simple setup here where from the client side, when I attempt to make that connection, initially I will see that here in connection state change telling me that I've connected to the server. So great, as soon as I've connected, the next thing I'm going to do is attempt to discover services. I want to know all the services on this device to make sure that the one I'm interested in is actually there. Okay? So that is going to trigger, again, another asynchronous call on services discovered. So in that case, I'm going to loop through all the services that I find, make sure that I have the right service available to me, and then I'm going to attempt to read that elapsed time characteristic from that service. Okay, so this is all just happening one after the other. This isn't as a result of me clicking a button or anything like that. Then the read characteristic method is going to trigger the on characteristic read, yet another callback, right? So This will get triggered a couple different times throughout the app, but essentially inside of here is where I can determine if the characteristic result that I get back was for the elapsed time, pop that into that text field in the UI, and if it was the offset value, then I actually display that date somewhere else in the UI too. So anytime I get a read back from either one of these, I'm going to just pop them up into the UI, again using a handler because this is not the main thread. Okay, remember that. The other thing that I'm doing is for this elapsed time, as soon as I've gotten the initial read, I enable notifications on that call. Okay, so this, now I don't have to read this characteristic anymore. Anytime the server calls that notified characteristic change that we just saw, I'm going to get a call here. That's all set up at this point. Okay, and in that case, it's going to come through on characteristic changed instead of on characteristic read. So I have the same basic block of code in there where it just pushes that value up to the text for now, so you can see it in the UI. So for every notification or for the initial read, it's just updating that counter with the new data. Okay? And then the final thing that we saw was that I could push that little button to set the new time offset, and it would fire that off to the device. Okay? That was inside of this update button, and this is just some basic code that showed that dialog. And then once I get whatever the timestamp was from that dialog that was set up, we get our characteristic from our service. We set that characteristic's value, and we tell the server we would like to write that characteristic on the server. Okay? And then that's where it updates that piece. And then remember the code on the server side, as soon as a write happened, it triggered a notification. So that's why immediately on the client side I saw the update. Okay? Questions on that? I finished exactly on time. So, thank you. So, I don't know if they need this room or not, but obviously if you guys have questions, maybe just come up here and we'll chat about this stuff so that other people can clear out. So come on up. So the sample code is on GitHub and the link to that is in the slides.